Hello everyone and welcome back. In this video we're going to kick off the implementation of our noise brush. Now before I hand it over to Lee, the first thing I would like to point out is that Lee has already brought in the noise class, the different CS files that we created in the previous session over, well, creating noise. So that is now available to us. There's been no modifications to the code inside with the simple exception of namespace. Outside of that, everything else is exactly the same code-wise. Lee, is there anything else we want to add, or that do it and we're ready to get going?
As far as the noise is, it should allow us to make any call on it like we did with our other example. That's the nice thing about it. But other than that, just a little description of what the noise brush is, because the noise brush, if you look at some of the other brushes like the soft and hard edge brush that we've done, the procedural, where we're determining the sample that we're returning based off of some sort of calculation, the noise brush is kind of our halfway house. We're getting away from pure procedural brushes, but we're not in pure stencil type brush. This is kind of our little halfway point. And I wanted to bring that that fact up in the beginning of this video, because while the noise is definitely procedural, we're going to be using it to generate a texture, and we're going to sample that texture like like we would be with our stencil brushes. So we're going to start with the noise brush, because the things that we're going to learn here are going to carry forward into our stencil brush. But it's like I said, it's our halfway point. So we're going to go from procedurals into stencils after we finish up with the noise brush.
Okay.
But let's get started with the noise brush. To get this going, we're going to need a couple of things, those being a private static noise, because we can't have noise without noise. So we're going to bring in our noise, and there's ReSharper giving me my using statement. I'm going to call this noise, and I'm going to create a new noise, but I'm going to use the second overload. We've got two overloads. We've got the default, and we've got one where we can specify initial values. I want to specify those initial values here. These are just a good little starting point that I was playing with, that I kind of like the look of, so we'll use that. I'm going to use a simplex noise. We're going to use 4 octaves of that noise. The frequency will be set to 0.02. That's a float. Our lacrinarity will be set to 1.9, and our persistence will be set to -1.6. Now, for those of you who were following along when we were playing around with the noise at the end, these are settings that are very close to the results that gave us the lava lamp looking example. So this just gives us large splotches of area instead of a high frequency noise. And those type of noises work very well for forming little land masses, where high frequency noise with our meshes as sparse as they are may not give a very realistic look to it. So, but that's why I chose these initial settings for our noise brush. That's, if you remember also, we discussed that the way the brushes are set up is I'm planning on reusing the brushes to work with texturing. So while these settings work very well with sculpting, they could work very well with painting textures as well. But your high noise would also, or your high frequency noise textures would work well with painting textures, which is why we're going to allow this type of brush. So if you wanted to go in and very quickly put all kinds of different looking patterns to your textures that you're painting, let's say you're putting in a desert, and the problem is with deserts, if you've only got one type of sand, everything looks like a repeating pattern. This type of noise brush would be able to allow you to go in very quickly, break everything up, which is why we're playing with it. But it also is useful for sculpting. All right, now we've got the stencil and icon inherited from our brush, but we need to do some setup work. Right now, we're setting our icon to be our test pattern, which we're loading in, and we don't really want to do it that particular way. What we want to do is reuse our stencil to be our icon, and we're going to have to adjust things accordingly. So we're going to remove this line of code for now. So that worked well. All right, there we go. I want to make sure everything lined up. Now we're going to take our stencil and we're going to create a new texture for it. Because we're not loading anything out, we're going to create something from scratch. So this is going to be a little bit new. So we're going to create a new texture, 2D. I want to make a texture that's 512 by 512. I'm going to use a texture format of RGB alpha 32. Now the reason I'm using an alpha texture is because this is going to be a stencil. I want it to have alpha and it fade out at the edges, so we're going to use an alpha texture. And I do not want mip mapping on this, so I'm going to set it to false. A couple of other things that we need to do before we can use this is we're going to set our stencil to filter mode, and that filter mode is going to be a point. So we're not going to use any blending or interpolation on it, and we're going to take our stencil's wrap mode and we're going to set it to clamp. All right, come on, you can find it for me. There it is. So this will make sure that our stencil doesn't repeat. Now the next part of this is actually creating our noise texture. So I'm going to create another method. This is going to be a private void, and it's going to be called update noise. Now for this to work, we need to go and get our pixels. To get our pixels, we're going to call stencil.setPixels, and we're going to set all of them at once as opposed to looping through one at a time. Now from here we need to figure out how big are we going to make our texture. This is where things get a little screwy. I'm going to set a starting point of 10 by 10. So we're using this overload. So yeah, we're setting a start position. So instead of starting at the 0, 0 coordinate of our stencil, I'm starting in 10 pixels from each of the edges. And because we're using 512 as our texture size, I'm only going to draw out 492 pixels. So I'm setting our width at 492 by 492. Now when you look at that, that gives us a 10 pixel border all the way around the edges. And I'm doing that to force our texture to have a black border because I don't want any of our noise to reach all the way to the edge, which could cause a problem that we have with mip mapping where it starts showing red. So by forcing it to only set the pixels that are a little bit closer in, then we can ensure that there's a black border all the way around the edge. Now we need to pass in an array of colors. The nice thing is we've already set that up with our noise, so we can tell it to go and get values. And with get values, all we have to do is give it a start point. We're going to say start at 0 by 0, and our size is going to be 492. This will return us a color array that is 492 by 492 pixels or colors total, which we can pipe right into our stencil set pixels method, which will set all of our pixels for us. Now, this will not this is kind of funny. This will not always take effect. It's hit or miss. Now, if you've ever created your own textures and you've gone ahead and you've set the pixels and you've run your test and you get back, who knows what you get, but it's not what you thought you should have gotten. It's because you need to hit stencil.apply. So you've got to make a call to stencil.apply every time you set your pixels. Otherwise, those won't necessarily get applied. Now, that's kind of weird because sometimes it will do it, but then you'll see like magenta pixels or random pixels throughout the image. It's just meaning that it hasn't allocated the right memory and you're pulling from some unknown location. So make sure that you always call stencil.apply. The other part, and actually before I start coding this up, it's easier if I give you a little visual
Yeah.
of what I'm going to be doing. So let's say that this is our texture. So technically it's a 512 by 512 and it would be set all the zeros because there's no information in it. Now what I want to do and what we've done so far with the set pixels is if I take this image and I modify our selection and I think I can border it by 10 pixels. No, so it's going to have to be 20. So Control D, let's see, select. So modify. So I'm going to border it by 20. This is going to basically inset everything inside of here. If I reverse my selection, the only thing that's selected is the inside part. Now, when I call the noise get values and I'm populating it, if this works the way I think it should, if I call render.clouds, it feathered. That would figure. All right, let's do this a different way.
Well,
Yeah,
aren't some of those settings at the top?
What's that? What settings?
Don't some of those options at the top for that help with that?
Inside of my selection? Or
like, never mind. Keep doing your thing.
This is like going, which settings are you speaking of? These? This is for the gradient.
Yeah, I know.
Okay. All right. So let's do it this way.
I'm not Photoshop guy.
Yeah, well, after my little, I wish we could make that stuff lowercase. Apparently, I'm not either, but.
Oh, come on. It should be fun to make fun of coders who try to get around in Photoshop.
Yeah.
Woo!
Okay, so let's pretend that this is exactly 10 pixels on each side border. I'm cheating, but otherwise it's going to take me forever how to do that right. Actually, I could do it, but I don't want to. So now we have our clouds inside with a black border all the way around. Now, yeah, great, but if you tried to apply this to the terrain, you're going to see very hard edges along the outside.
Yeah, to say the least.
So, yeah, we don't really want that either. So what we're going to do is take a radius and will my mouse go out far enough? Yeah, that's definitely far. So I'm going to take a radius that goes out to right about the edge of where the noise ends. If I invert this, and then I delete everything on the outside, then I make sure that everything stays inside, and I've got this nice circle. But I still have a hard edge noise. So this is just like the hard edge brush, but it's got noise inside of the center. And what I would like for the noise is to be more of a soft effect. So what I'll do at that point is go ahead and recalculate the values based off of, in this case, I'm just using a gradient, but I would use a linear check that will, in effect, calculate from the center out to the edge, and it's going to fade out across that. So at the outer edge, those are going to be all blended to zero, and the highest effect is going to be in the center. This is kind of hard to see visually, so to compensate for that, if I put a solid color, let's put a black solid color down, move that underneath, we'll do that. So this is, in effect, what I'm doing with the noise. So while we're adjusting transparency as well, we're taking the noise, making sure that the most effect of the noise is in the center and it bleeds off to the edge and gives us a very nice looking type of brush, which is then what we use as our stencil for the noise. So that's pretty much all we're doing, and we're going to do it with, a handful of lines of code. But I wanted you guys to have a visual of what we're about to code, because code isn't always easy to figure out. So let's go ahead. There we go. We're going to use this as a nested loop. So we'll start off with the Y values. And ReSharper IntelliSense fighting with me. We're going to loop through our stencil dot height. And this time we'll use X. I'll just type it this time, otherwise it'll cause more issues. And we'll use width. Now, if you wanted to get really fun with it, you could sit here, and because we use this the 10 by 10 by 492, we could technically start off at 10 by 10 and then subtract 20 from the end. This will give us the effect of that border, because we know the border is going to be black. So with the border being set to black, I don't need to calculate those pixels, so
Right.
this will save us some performance. At least I think so. This is another one of those on-the-fly changes that I'm making, so who knows what it'll really do. So let's start off with another variable. We'll call this V. Now we're going to get a new vector, and I'm going to set this to be our X position minus 256 by Y minus 256. What I'm doing here is I want to figure out the distance from the center of our image. And matter of fact, let me do this. Otherwise, it's just hard-coded values. So this is, and I did that wrong too. So this is width, and then we'll use height for Y. What I'm doing is I'm calculating out the halfway point of the image. And I want to be able to calculate the magnitude of this point from the center. And the reason I want to do that is we're going to do a comparison that's going to basically say if magnitude of V is less than or equal to our height, or any one of these, it doesn't really matter because it's going to be a square image.
Right.
So if I take the half value, so if we're less than, half the distance, then we're going to go ahead and let me modify this too. This has to be the half distance minus, so is it 20? Width is going to be 10, 20, so half distance minus.
Isn't it just going to be minus 10?
Yeah.
Yeah, it's because you're only dealing with 1/2.
Well, I'm taking the overall, so it is 492, so it's actually minus 20, then divided by 2. So I'm taking the overall width, which is 512, dividing by half, which is 492. So now it's just saying as long as the magnitude is less than this 492, we're going to be adjusting the color value of that pixel one way, and if it's greater, we're ignoring it. So we're going to be doing an interpolation out from the center to the edge of the ring, which is 492 pixels out.
Okay.
And then if that is the case, we're going to go get the color. So we're going to make another variable called color. We're going to say stencil dot get pixel. Now this, come on, get pixel. This is different than the get pixels. This will only return a single pixel at a time, not both of them. So we're going to say get the pixel at x by y. To that, we're going to multiply 1 minus v dot magnitude divided by the same equation that we came up here, which is going to be our half value. Why does it do that? I hate that. Sorry.
I'll find the settings and change
I got to
those.
fix it. The OCD dictates it must be right. All right. So it's basically if we're at the outer edge, which based on these calculations is 492. So if we're at the edge of with a magnitude of 492 or half of 492, which is, wow, that would be 246, I think. Is that right? Yeah, I think that's right. 246. So if magnitude is 246 and this returns 246, this half of the equation is 1. 1 minus 1 is 0. So at that edge or anywhere past the edge, we're going to multiply our pixel by 0. So we're driving our pixel color down to 0 as we approach that edge. Once we pass it, it will be 0.
Okay.
Now, that is just adjusting the color. We still have to go back and reassign that. So that gets us back into a set pixel. We're using set pixel because we're only doing one, not both. So x by y, and then we send in our modified color. So that will cover that condition. Now, else. If we are outside of this magnitude, we want to do the stencil, set pixel, x by y again. We're going to do a new color, and that color will be 0, 0, 0, 0. So we will force any pixel that's outside of that magnitude or outside of that outer circle to be 0. Because we know once you're past that, that was that first part when we had the hard edge.
Mm-hmm.
This is the part that forces that hard edge.
Right.
And this is the part that forces the alpha down based off of that. And then once we go there, we apply our pixels. So that takes care of all of the update noise part. Before I forget, we're going to take this, and that will be the last thing that we do inside of our noise brush. After we set up our stencil, get it all, or create our new stencil, set up its settings, we're going to update its noise. We go through, we get our noise, we do the manipulations to give us a nice stencil from it. We apply the new texture to the stencil to make sure it has the right information. In the next video, we have to come back to our sample method, and we have to define or devise a way that we can take our sample point and figure out what our sample point would be in local image space of this stencil so we can return the correct information based off of the stencil back to our tool.
Okay.
But we will take care of that in the next video.
Awesome. Okay, well with that, that is going to wrap up this video. Thanks a lot.